As we continue with functions, let's go back to geometry where we learned the area of a circle. The function capital A of r that determines the area of a circle with radius r, you may remember that area equals pi r squared. So pi is just a number. It's just a real number, 3.14159 ... r is the radius of the circle. So a is a function of r. So we could write this like a of r is equal to pi r squared. And what that says is the area of a circle with radius r is pi r squared. So if we find the area, find this circle having radius 12, find the area of that circle, we would simply say the area of a circle with radius 12 is pi times 12 squared, which would be like pi times 144. I'll write it like 144 pi. And if you wanted to plug it into a calculator and get a good approximation of it, that would be 452.39 square units. I didn't say whether we were talking about inches, but if r were the radius in inches, then we would put square inches right here. And again, this is just an approximation because we don't know what pi is exactly when we write it out as a decimal. So it would be 452.39 square units, whatever units we're talking about. All right, the next one. Find the function that determines the price of oranges given that oranges cost $2.29 per pound. And then discuss the domain and range as well. Well, that's fairly straightforward. The cost of x, we'll say x is the number, let me write that down, number pounds of oranges. Well, if x is the number of pounds of oranges, then the cost is going to be 2.29 times x. Simple as that. If you have 1 pound of oranges, that would mean x is a 1. The price would be $2.29 times 1, or $2.29. Now we'll discuss the domain and range. The domain is all the possible values that you could plug in for the weight of the oranges. And I guess anything greater than 0 would be acceptable, even though there's probably no orange that's 0.0000 pounds, 0.1 pounds, something like that. But we could just say that the domain is all positive numbers, and the range would be all of the possible values you would have to pay. 2.29 times a positive number. That you could say basically is any positive number as well. I think the point is that you couldn't have a negative number of pounds of oranges, and you couldn't pay a negative price. So they both are positive numbers. All right, well, let's take a look at a couple of graphical examples. We have two functions here. Let's look at the first one. I want to find the domain and range of that function. Well, one way, these are called continuous functions because you could draw both of them without lifting your pencil. And these are nice functions to look at because the domain and range, let's look at the domain. The domain would be the leftmost point to the rightmost point. It goes left to right. This is the domain, this region right here. From, let's say that's 0, this dot right there would be the origin. So it looks like -1, -2. It looks like from -3 to 1, 2, 3, 4 to 4. This would be the domain. So you could say, if you wanted to, you could say the domain is all of the x values in between -3 and a +4. We'll learn later that you can write that like an interval, which would be this. The domain is this interval. This means all of the points from -3 to +4. Everything from -3 all the way through 4. Well, the the range is going to be the lowest height right here to the highest height of the function. This would be the range. So the height of this lowest point is -1. The height of the highest point is 1, 2, 3. So we could say that the range is, I'll say all of the y values. Sometimes we use y for the height of the function, and x is the left or right. So it would go from -1 height up to a height of 3, or -1, 3 in square brackets. Here's the domain. Here's the range. And another way to consider the domain and range, let's look at this second example. If you could draw the smallest possible rectangle made with horizontal and vertical line segments that encompasses this function, that'll help us out. Looks like it would be something like this. The domain is the left-hand side to the right-hand side, and the range is the bottom to the top. So the domain goes from the left to the right. It goes from -1, -3, -2, -1, 0, 1, 2, 3, 4. -3 to 4. I'm going to write it like an interval to save some space. Is the domain of this function goes from -3 on the left all the way to +4. And what would the range be as an interval? What is the lowest height? It goes from this to this. The height of this vertical segment is -1, and this one is 1, 2, 3, that has a height of 4. -1 to 4, the domain and range. And you could have used that triangle or the rectangle trick over here as well. The smallest rectangle that contains the entire function. It goes from -3 to +4, and in height, it goes from -1 up to 3. Okay, let's go way back. A cell phone company used to charge $45 a month plus 15 cents for every minute used. So what is the charge for 750 minutes? Let's write an equation, or the cost function. So we'll say, let's let t equal the number of minutes. That means the number of minutes that the cell phone is used each month, or for a particular month. Well, what is the cost for that many minutes? Well, it's certainly going to be $45, because even if you talk 0 minutes, you have to pay that. Plus 0.15 cents. 15, that actually should say 15 cents. $0.15. But actually, I think that would have, let's say, 15 cents is $0.15. So it'd be 45 plus 0.15 times t. As simple as that. It's $45 no matter what. Even if t is 0, you have to pay $45. If t is a 1, it'd be $45 plus 15 cents. If t is a 2, it'd be plus 30 cents. And so on.